This video is on the formula for time versus intensity. You could also call intensity your effort, your rate that you work, or the velocity that you're working or traveling. So basically, if you have a job to do, but you want to do it in a different amount of time, and you want to spend more time doing that job or less time doing that job, then how much harder do you have to work or how much less hard do you have to work? So it's real simple. Okay, so what we have here is, let's talk about a college degree. Person A, actually, let's start with person B. They're going to get a 4-year degree in 4 years. So 1 degree in 4 years. What you can do is divide both your numerator and your denominator by 4, or you can multiply the numerator and denominator by 1/4, and that comes out to be 1/4 of a degree per year. So every year that goes by, they get 1/4 of their degree. Person A is going to be a little more ambitious and get that degree in 3 years. And again, what I did here is I took the numerator and denominator, multiplied both by 1/3. Notice 1/3 divided by 1/3 equals 1. So when you multiply anything by 1, you get the same number. So what we have here is 1 degree in 3 years equals 1/3 of a degree per year. Person C here, they're going to take a little bit longer to get that degree. They're going to do it in 5 years. So that'll be 1 degree in 5 years, or 1/5 of a degree per year. And this will be the efforts of A, B, and C. So how much harder do they have to work? How much more do they have to study compared to somebody else? How much less do they have to study each night? So this is what it looks like. All it is effort and time are inversely proportional. 1 over time equals effort. 1 over effort equals time. And your effort is the same thing as the rate that you're working. If you're working at a faster rate or whatever, or velocity, it's equivalent to the equation of distance over time equals velocity, and therefore distance over velocity equals time. So let's look at the situation right here. If you do one job in a certain amount of time, that's your effort in jobs per time. So if you want to double that effort, then that means you can do 2 jobs in the same amount of time, or do that one job in half the amount of time. And that means you're putting in twice the effort, or you're working at twice the rate. If you're, for example, working on a degree, that means you're taking twice as many classes. Or if you're making widgets, that means you're making twice as many widgets per hour. And you got to have those widgets. We can't get by without them. I just gave some more examples here for the distance and time. If you go 2 times the distance with the same velocity, it'll take twice the amount of time. Or if you travel at half the velocity, it'll take twice the amount of time also. So next page. All right, what we have here, let's see. I wonder if, actually I need to reverse this here. Here we go. Okay, so we have person A, B, and C. You could also say this is like mowing a yard. That's another good example. They can mow 1 yard in 3 hours or something like that. So here's how you can compare your efforts. How much harder or less hard does one person have to work compared to another person? Let's just take the new effort divided by the baseline effort, or the new velocity divided by your baseline velocity if you're talking about cars. If one car goes twice as fast, they get there in half the time. So let's take the effort of A compared to effort of B. B is the baseline. 4 years is the average amount of time. Typically, I've heard it's usually about 5 years, but we'll just pretend it's 4 years because it's called a 4-year degree typically. So at any rate, we have new over baseline. So let's take the effort of A compared to the effort of B. Effort of A is the new amount of effort. Their effort is 1/3 of a degree per year, and then effort of B is 1/4 of a degree per year. 1/3 divided by 1/4, that's 1/3 times 4, that equals 4/3 is the effort. Notice here, because they have the same numerator, that 1 divided by 1 will cancel out, which means they disappear. So in the final answer, they are not present. So what this means is person A is they're doing the job in 3/4 the amount of time. Therefore, you can just invert that, and they have to put in 4/3 the amount of effort, which equals 1 1/3. So let's see, person B, they're getting that degree in 4 years. Let's say on average they have to study 1 hour per night. Then that means person A will study 1 1/3 hours, or 1 hour and 20 minutes. And by the way, I was thinking about, should I use the term cancel or divide out, because they both work in this situation. Since I'm taking 1 divided by 1, and that equals 1, so I multiply this whole thing by 1, they are canceling, they disappear. If this was plus 1 divided by 1 or plus 5 divided by 5, then 5 divided by 5 equals 1, so I'd be doing plus 1. So in that case, you'd say they divide out and they don't cancel. So I'm just saying that because I think it's very good to be precise in how we speak and make sure we don't make any little linguistic or terminology errors. Since we're dealing with 1 in the numerator of all these situations, A, B, and C, we can say A is Amy, B is Becky, C is Charlie. So A is getting 1/3 of a degree per year. Becky is getting the degree in 1/4 of a degree per year. Charlie's getting 1/5 of a degree per year. So what we can say here is when we compare Amy to Becky or A to B, A here is putting in, they're getting the job done or getting the degree in 3/4 of the amount of time. So we can just invert that, and that means they're putting in 4/3 the amount of effort. And that's just a simple inversion logic. Or you can simply use method number 3 here. 1 over time equals effort. 1 over 3/4 equals 4/3 the effort. Also, the reason I like to do these videos, or part of the reason I like to do them, first off, I just like to do them and I like to learn things. But also, I'll think that I'm right sometimes, but I'm actually wrong. Or I'm just partly right. So for example, this whole inversion thing I'm doing here, where if A puts in, or if A does the job in 3/4 the amount of time, that means they're putting in 4/3 the amount of effort. I did not realize that this only works if they have the same numerator. And in this case, the numerator is 1 in both situations. So I caught that at the last minute before making this video, so I thought that was kind of interesting. Okay, next page. Now we're going to make it more complicated and show what happens if the numerators are not the same. Amy will do 4 jobs in 3 hours. Becky will do 5 jobs in 2 hours, or you can call them A and B or whatever. So job per hour, that is the effort. So the units on effort will be J per H, jobs per hour. So that's effort of A, and then here's effort of B. In this case, you do have to divide one effort by the other. So let's look at effort of B compared to A. So we'll put A in the denominator. Effort of B is 5/2. So let's take 5/2 divided by 4/3, and that will equal 15/8 right here, or 1 7/8 of the effort. So in this case, I guess I forgot to say these could be like making widgets. A is making 4 widgets in 3 hours. B is making 5 widgets in 2 hours. B is putting in a greater amount of effort, and so they are putting in 1 7/8 effort, or almost twice the effort. I also like to show the wrong way to do things for a couple of reasons. First off, it's always good to explore as many possible methods because that's how you find easier methods. But also when you discover the wrong way to do something, then you'll know why the right way is right and the wrong way is wrong. So in this case, let's say we didn't notice that the numerators were different. So we thought the numerator was the same. So let's just take B here. They do their job in 2 hours. A does it in 3. So that's 2/3 of the amount of time. That would equal 3/2 the amount of effort. But that is wrong because that does not equal 15/8. And then I just showed this because it's nice to know that the old saying, there's more than one way to skin a cat, which isn't a very pleasant saying, but it's nice to know that there's different methods to do the same job or to do the same math problem. And it's always good to know all the possible ways because occasionally you're going to come across somebody that learned how to do the same problem in a different way. And from my experience, people tend to only learn the way that they were taught, and they don't understand other people's ways. So thus, you don't know if their way is correct or incorrect because you simply don't understand it. So here I'm going to show a different method. Let's give them the same numerator. Let's say we come across somebody that learned this method. So A has 4/3 right here, 4 jobs in 3 hours. B has 5/2, 5 jobs in 2 hours. The numerators are 4 and 5. They both go into 20. So 4 times 5 is 20. So if we multiply the numerator by 5, we have to do the same to the denominator. We do the same thing to person B here, or Becky. So now we can take the effort of B divided by the effort of A. That'll be 28 divided by 20/15. And notice here that the 20 divided by 20 will cancel. They will be gone. And also notice that since we have the same numerator as 20 in both cases, we can simply take an inversion. So person B is doing the job in 8/15ths of the amount of time. So 8/15ths of the amount of time will equal 15/8 the amount of effort.